Hey everyone, and welcome. Today, we are going to tackle one of the most powerful tools in C programming, functions. You'll see how they're the absolute secret to writing smarter, not harder. All right, let's get into it.
So, have you ever felt this? I bet you have if you're just starting out. That feeling you get when you're copying and pasting the same chunk of code for like the third time, and you just know there has to be a better way? Well, guess what? There is, and that's what we're here to talk about. Without a plan, your main function, which is really the heart of your program, can just become this giant tangled mess of code. It's confusing to read, it's a total nightmare to debug, and trying to update it feels like playing Jenga. It's a common problem, but definitely not a place we want to stay.
To fix this mess, I want you to imagine something super simple. A vending machine. Yeah, a vending machine. It sounds kind of silly, but it's the perfect analogy for the powerful idea behind functions. Trust me, this little mental model is going to make everything just click.
So what is a function, really? At its core, it's just a self-contained little block of code that's built to do one specific thing. Just like a vending machine is built to do one thing, give you a snack. You don't need to know about all the gears and wires inside. You just know what it's supposed to do. The whole thing really boils down to 3 simple steps. First, you give it an input. That's your money and your selection. Step 2, the machine does its thing, a hidden process. And step 3, you get a predictable output, your snack. Functions work in that exact same way. Input, process, output.
Okay, that's the big idea. Now, let's get into the nitty-gritty and see how this vending machine concept actually translates into the C code that you'll be writing. It all comes down to 3 key steps.
First, you've got the declaration. This is basically putting a sign on the vending machine, telling the rest of your program, hey, over here, this function exists and this is what it needs. Second is the definition. This is the machinery inside, the actual code that does the work. And finally, the call. That's you, pressing the button and making it all happen.
So let's really nail down those inputs and outputs. In C, we've got some official names for them. The inputs, we call those parameters. That's the information you give to the function, your money and selection. And the output, that's the return value. That's what the function gives back to you when it's done, your snack. Simple, right?
Now, the cool thing is, you don't have to build every single tool from scratch. C comes with a bunch of library functions already built for you, like printf for printing stuff on the screen. But the real magic, the real power, comes from user-defined functions. That's where you get to build your own custom tools, like a function to calculate the area of a circle.
All right, enough theory. Let's actually see this in action. Because seeing the transformation from messy code to clean code, that's when it really hits home. So let's check out a quick before and after.
Okay, take a look here. On the left, we've got the before. See how all that math for the circle's area is just stuck right in the middle of main? It works, sure, but it's clunky. Now, look at the right. Wow. See how clean and simple main is now? We just call our calculate area function when we need it. All that complex logic is neatly tucked away, ready for us to use whenever we want.
And listen, this isn't just about being tidy. This is a fundamental shift in how you write code. Honestly, mastering functions is like unlocking a new superpower. It completely changes how you approach and solve programming problems.
So why is this such a big deal? Well, it really comes down to 3 huge wins. First, code reusability. You write that calculate area function one time, and you can use it 100 times if you need to. Second, better organization. You can break a massive, scary problem down into small, logical chunks. And third, you get clean, maintainable code that you or someone else can actually understand 6 months from now. And this gets at something really deep about what it means to be a good programmer. There's this fantastic quote from Martin Fowler. Good programmers write code that humans can understand. We're not just writing instructions for a machine. We're trying to communicate ideas clearly to other people and, yeah, to our future selves. Functions are maybe the best tool we have for that.
So as we wrap this up, I've got a challenge for you. Go look at a project you're working on right now, find that chunk of code you've written more than once, and just ask yourself, what repetitive task are you going to turn into a function first? Go on, give it a shot. Thanks for watching.